A very warm good morning to one and all. In this video, we are learn the subject EC3452 electromagnetic field. In electromagnetic field, there are 5 units. In this video, we are learn about unit 1 introduction. In this unit, important questions which is repeatedly asked in Anna University question paper is divergence theorem, Stokes theorem, and problems asked in coordinate systems, gradient and curl of vector field. In this paper, mostly the university questions covered with problems. The first unit only problems only they are asking. Let's get into the unit. First topic, electromagnetic model. First topic, electromagnetic model. Electromagnetic, which is both electric and magnetic phenomenon we are going to study in this unit. Electric and magnetic fields are closely related to each other. First of all, consider a magnet. Magnet has of 2 poles, north and south pole. It has its own effect surrounding around it. That magnetic effect is experienced by placing another magnet near to it, like this. If we placing another magnet near to it, it may experience both attractive or repulsive force. If we place a magnet at some point, its attractive and repulsive force may increase. At some other point, its attractive and repulsive force may less. It means even though the magnetic effect surrounds the magnet, its effect differs at each and every point. The field experienced by the magnetic effect is called magnetic field. This is the magnetic field lines, and similarly a current carrying conductor, a current is flowing through the conductor, the magnetic field produced around the conductor. Thus both electric and magnetic fields are closely related to each other. In this subject we are learn about this electric and magnetic fields. For analyzing the electromagnetic theory, a vector analysis, that is a mathematical tool which is necessary to understand this electromagnetic field. And next topic in this unit is units and constants. There are, for the uniformity, for the sake of uniformity, the SI units, that is system of international units, categorized 3 units, that is fundamental unit, supplementary unit and derived units. First, fundamental units. Fundamental units is of 7. It is doesn't depend upon any other unit, so it is come under fundamental units 7, and supplementary units number 2, and derived units number of units or comes under derived units. Fundamental units is of 7. They are unit of mass. Unit of mass is kilogram. It is represented by the letter kg. Then unit of length, meter, represented by the letter m. Similarly, a current, ampere A. Unit of time, second S. And unit of temperature, Kelvin K. Unit of luminous intensity, that is cadence CD. And unit of amount of substance, that is mole, represented by the letter MOL. These are the 7 fundamental units. And derived units, there are a lot of derived units. Examples: resistance, capacitance, inductance, area, volume, density are all come under derived units. And some of the constants we are using in this electromagnetic field theory, they are electron charge. The value of electron charge is 1.6 into 10 power, electron charge, it is represented by the letter E, and the value of electron charge is 1.6 into 10 power minus 19 coulomb. The value of electron charge is represented by the letter E and it is 1.6 into 10 power minus 19 coulomb. Next, permittivity of free space. Permittivity of free space is represented by the letter epsilon naught and the value of permittivity of free space is 8.854 into 10 power minus 12 farad per meter. 8.854 into 10 power minus 12 farad per meter. Then permittivity of electron charge E equal to 1.6 into 10 power minus 19 coulomb. Permittivity of free space epsilon naught equal to 8.854 into 10 power minus 12 farad per meter. Then permeability of free space mu naught, it is 4 pi into 10 power minus 7 Henry per meter. And C, let us see, represents the velocity of light. Velocity of light C equal to 10 power 3 into 10 power 8 meter per second. These are some of the constants we are using in this electromagnetic theory paper. Let's get into the topic. Next topic, coordinate system. Let's get into the next topic, coordinate system. There are 3 coordinate systems. Let's get into the topic, coordinate system. There are, why we are going for coordinate system? What is the purpose of coordinate system? To describe a vector. As I already told that electromagnetic field theory is studied by using a mathematical tool which is a vector analysis. For this vector analysis, to describe the vector accurately, it is necessary to have some reference direction. For that, various coordinate systems are available. Now we are going to use about only 3 coordinate system, that is number 1, Cartesian coordinate system. Cartesian coordinate system and cylindrical coordinate system. Third one, spherical coordinate system. 3 coordinate system. Why we are going for 3 coordinate system? To have some reference direction, we are going for 3 coordinate system. That is Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. First, Cartesian coordinate system. First coordinate system, Cartesian coordinate system, which is also called as rectangular coordinate system. Rectangular coordinate system or Cartesian coordinate system. Cartesian coordinate system, the points are represented by the letters x, y and z. Now let us increase each coordinate, each point to a differential length dx, dy and dz. So differential length dx, dy, dz are differential length in x direction, dy is a differential length in y direction and dz is a differential length in z direction. To calculate the differential length dl vector, to calculate the differential vector length dl vector, the formula is dl vector equal to dx ax vector plus dy ay vector plus dz az vector. This is the formula used to calculate differential length vector dl vector equal to dx ax vector plus dy ay vector plus dz az vector. Likewise, differential volume. Next we are going to calculate differential volume, which is represented by the letter dV. dV equal to dx, dy and dz, and differential surface. Differential surface vector is represented by ds vector. So, ds vector is calculated by the formula ds vector an vector. This ax, ay, az are called unit vectors in corresponding direction. Ax is a unit vector in x direction, ay is a unit vector in y direction, az is a unit vector in z direction. This an is consolidated form of ax, ay and az. For calculating the differential surface vector normal to x direction, which is represented by dsx vector. Differential surface vector in x direction is calculated by the formula dy dz ax vector, which is in the direction normal to the direction x. Similarly, for differential surface vector normal to y direction, which is ds y vector equal to dx dz ay vector. Next, ds vector normal to z direction, ds z vector equal to dx dy az vector. These are the differential volume, differential length, differential surface vectors for Cartesian or rectangular coordinate system. Similarly, for another coordinate system, which is cylindrical coordinate system. This cylindrical coordinate system is represented by the letters. Point is represented by the letter r, theta, z, or r, pi, z, whatever may be r, theta, z or r, pi, z. In this, we are using r, pi and z letters to represent the point in cylindrical coordinate system. Next coordinate system is cylindrical coordinate system. Cylindrical coordinate system, point is represented by the letters r, pi and z. Differential length. Differential length in cylindrical coordinate system, dl vector equal to dr ar vector plus r d phi a phi vector plus dz az vector. From previous to, that is Cartesian to cylindrical coordinate comparison, dr they are there dx, d phi there dy, dz dz, but this r term is included in cylindrical coordinate system. Why this r is included means, in pi direction the angle is, in pi direction angle is moved, angle is differential angle change in the direction d phi, then the length, there exists an differential arc length in pi direction, that differential arc length is represented by the letter r. So, differential length in cylindrical coordinate system is dl vector equal to dr ar vector plus r d phi a phi vector plus dz az vector. Similarly, differential volume for cylindrical coordinate system is dv equal to r dr d phi dz, and surface, differential surface areas for a normal to r direction is ds r vector, that is differential surface area normal to r direction is r d phi dz ar vector. Differential surface area normal to pi direction is ds pi vector is equal to dr dz A pi vector. Then differential surface vector normal to z direction is ds z vector equal to r dr d phi a z vector. These are the formulas for calculate differential length, differential volume, differential length, differential volume and differential surface area in cylindrical coordinate system. Next coordinate system is spherical coordinate system. Next coordinate system is spherical coordinate system. Now let us learn about the relationship between Cartesian and cylindrical coordinate system. How to convert a Cartesian system to cylindrical system or cylindrical system to Cartesian system. What is the formula to convert from one coordinate system to another? First, a transformation from cylindrical to Cartesian. Transformation. Okay, first starts with Cartesian to cylindrical. Cartesian to cylindrical. Cartesian. What are the letters? What are the letters represented for Cartesian system? X, Y, Z. X, Y, Z. The points used to represent in a cylindrical coordinate system is R, pi, Z. Okay, the formula to convert a Cartesian system to cylindrical system is R equal to, we have to find R value, pi value and Z value, isn't it? So, R equal to square root of x square plus y square. Similarly, pi equal to tan inverse of y by x. Then z equal to z. These are the formulas used to convert a Cartesian system to cylindrical system. Cylindrical system, the point is represented by the letters R, pi and z. So, convert a point to R is R equal to square root of x square plus y square, pi equal to tan inverse of y by x, z equal to z. Similarly, a cylindrical system is converted into Cartesian. Cylindrical system to Cartesian. Cartesian system is also called as rectangular. Cartesian system also called as rectangular system. So, cylindrical, the points are R, pi and z. Cartesian system, the points are represented by the letters x, y and z. So, we are find the value of x, y and z. The formula to calculate x from the cylindrical points R, pi, z is x equal to R cos pi, y equal to R sin pi, z equal to z. This is a formula to convert a Cartesian to cylindrical and cylindrical to Cartesian. Please memorize this formula. The questions asked, they given a Cartesian number to convert into cylindrical coordinate system. So, please memorize this formula. Next, a relationship between Cartesian and spherical coordinate system. Relationship between Cartesian and spherical coordinate system. First, convert a Cartesian coordinate system to spherical coordinate system. Cartesian coordinate system, the points are represented by the letters x, y, z. Spherical coordinate system points are represented by the letters r, pi and theta. R, pi and theta or r, theta and pi. R, theta, pi. So, we are going to convert to spherical coordinate system. So, we are going to calculate r value, theta value and pi value. A formula to calculate r value. Calculate r value. R equal to square root of x square plus y square plus z square. Then theta value equal to cos inverse of z divided by square root of x square plus y square plus z square, and pi equal to tan inverse of y by x. Thus, these are the formula to calculate, to convert a Cartesian system to spherical coordinate system. Similarly, from spherical to Cartesian. Spherical coordinates are theta, pi. Cartesian coordinates x, y and z. Now, we are going to calculate x value, y value and z value from r, theta and pi. To calculate x, the formula is x equal to r sin theta cos pi, y equal to r sin theta sin pi, z equal to r cos theta. This is a relationship between Cartesian and spherical coordinate system. Memorize this formulas. In this, we are using this formula to convert one coordinate system to another coordinate system. Let's solve one problem. Okay, let's solve one problem. Problem 1, given the 2 points a of x equal to 2, y equal to 3, z equal to minus 1 and b of r equal to 4, theta equal to 25, pi equal to 120 degree. Find the spherical coordinates of A and Cartesian coordinates of B. From question, they are given 2 points A and B. A point is A of x equal to 2, y equal to 3, z equal to minus 1. Z equal to minus 1. So, points are represented by the letters x, y, z. From this we conclude that these points, that A point belongs to which coordinate system? That is Cartesian coordinate system or rectangular coordinate system. So, from Cartesian they have to find spherical coordinates. The formula to find a spherical coordinate from Cartesian coordinate is, the spherical coordinates, the points are represented by the letters r, theta and pi. So, formula to calculate r from x, y, z value is r equal to square root of x square plus y square plus z square. Similarly, for theta, for calculating theta, the formula is cos inverse of z divided by square root of x square plus y square plus z square. Then pi. Formula to calculate the value of pi is tan inverse of y by x. Tan inverse of y by x. Let's find out the value of r. Substitute the values of x, y, z in the corresponding formulas. So, square root of x value, what is the value of x? That is 2. So, 2 square plus, then y square, y value of y is 3, then 3 square plus the value of z is minus 1. So, minus 1 square. Let us calculate 2 square, 2 2s are 4 plus 3 square 9 plus minus 1, minus square panna plus. So, minus 1 square value is plus 1. So, total 10 square root of 14. The value of r is square root of 14. Next, we have to calculate theta value. Theta formula is cos inverse of z divided by square root of x square plus y square plus z square. So, cos inverse of z value, what is the value of z? That is minus 1 divided by square root of x square plus y square plus z square. This x square plus y square z square value we already found out for r. So, easily substitute the value, that is square root of 14, or find out the value of square root of 14 is 3.74. The value for square root of 14 is 3.74. Thus, cos inverse of minus 1 divided by square root of 14. Using calculator, we found out the value, that is 105.5 degree. Theta value is 105.5 degree. Then pi value. Pi value, the formula to calculate the pi is tan inverse of y by x. So, tan inverse of y value, what is the value of y? That is 3, and x, value of x is 2. Tan inverse of 3 by 2. While calculating, while using calculator, you are typing that tan inverse of 3 like this. You are choosing, you are pressing tan inverse of 3 divided by 2, means it does not give the correct answer. First, we have to divide this 3 divided by 2, and that answer is type here, tan inverse of answer. Like this we have to solve in calculator, otherwise the answer may vary, otherwise the answer may vary. So, tan inverse of 3 by 2, by using calculator we are solving, we get the answer, that is 56.31 degree. From question they given the point A, x equal to 2, y equal to 3, z equal to minus 1. From point itself we comes to a conclusion that the point A belongs to the which coordinate system, that is Cartesian coordinate system, because x, y, z. That Cartesian coordinate system they are asked to find the spherical coordinates. For the spherical coordinates, the points are represented by the letters r, theta and pi. So, formula to find out r from x, y, z is r equal to square root of x square plus y square plus z square, and we are substituting the values x, y and z in the formula and find out the answer. Similarly, for theta, the formula is theta equal to cos inverse of z divided by square root of x square plus y square plus z square, and pi equal to tan inverse of y by x. While doing problem solving in calculator, first solve this bracket only and then go for tan inverse of answer. Before solving the bracket, you are typing like a tan inverse of 3 divided by 2 means it does not give right answer. You have to solve 3 divided by 2 first. After getting an answer, you go for tan inverse of answer. Then only it gives a right answer. Okay, fine. We have find 1 point only. Next we have to find Cartesian coordinates of B. A Cartesian coordinate of B. B equal to B value, B is represented by the B is B of R equal to 4, theta equal to 25, then pi equal to 120 degree. Theta equal to 25, R equal to 4, theta equal to 25, pi equal to 120. So, B letter is represented by the letters R, theta and phi. The point is represented by the letters R, theta, pi. R, theta, pi means which belongs to which coordinate? R, theta, pi, it belongs to spherical coordinate. B point is belongs to spherical coordinate. They want to find what coordinate system? They want to calculate into Cartesian coordinate system. So, for Cartesian coordinate system, the letters to represent Cartesian coordinate systems are, what are the letters for Cartesian coordinate system? X, Y and Z. X, Y and Z. To calculate the x value, the formula is R sin theta cos pi. For the formula for y, R sin theta sin pi. Z formula R cos theta. So, we all know what is the value of R, theta and pi. Substitute the values in the formula. So, R, what is the value of R? 4, then sin theta, theta value is 25, sin 25, then cos pi, cos pi value, pi value 120 degree. By using calculator, we calculate 4 sin 25 cos 120, the answer is minus 0.8, 0.845. Then y value, what is the value of R? 4 sin 25 sin pi 120 degree, and the value, please do it in a calculator, value is 1.464. Then Z value R, what is the value of R? They given in the question, that is 4. Cos theta value 25, cos 25. So, 4 into cos 25 value, final answer is 3.625. Okay. B point, they given B point, that is R theta phi. From R theta phi we conclude that B point belongs to the spherical coordinate system. They asked to find into a Cartesian coordinate system. They asked to convert the spherical coordinate point into Cartesian coordinate point. So, for Cartesian coordinate system, the points are represented by the letters x, y, z. So, for each x, we have formula to convert from spherical to Cartesian, that is x equal to R sin theta cos pi, y equal to R sin theta sin pi, z equal to R cos theta. The value of R, theta and pi are substituted in the corresponding question. We are calculate, we get the value x equal to minus 0.845, y equal to 1.464, z equal to 3.625. Like this, they given points and convert that point into other coordinate system. In this way, the university exams, the questions may ask. In this video we are let's summarize the video. In this we are learn about relationship, how the electric and magnetic phenomenon are relatively close to each other, electromagnetic model, then units and constant. What are the units and constants we are using in this electromagnetic paper. Then next topic is coordinate system. What is the purpose of coordinate system? We need to describe a vector accurately, some reference direction we need. That reference, for that reference direction we go for a mathematical model, that is coordinate system. There are more number of coordinate systems available. Now here we use 3 coordinate systems, that is Cartesian, cylindrical and spherical. Cartesian coordinate system is also called as rectangular coordinate system, and we study the relationship between the Cartesian to spherical and Cartesian to cylindrical coordinate system. From that formula we have solved one problem. Let us memorize the relations between the coordinate system. That is a very important topic in this unit. Okay, thank you.